Hey, it's Jag. That worked out.
Yeah.
Well, since I spilled the beans on the edge-lit faceplate in the last video, I thought I would do a bonus follow-up and do a little bit of playing around with some LED strip lights and see how it would look. And it turned out really well. Let's just say this is part 6B for New Year's Eve morning. Sticking with my regular schedule, this will be released the morning of New Year's Eve. I have mocked up how it's going to look when I get the base pre in a cabinet. This is not the actual cabinet the base pre is going to go in. It's an unfinished cabinet for one of my my Jagsters, the 2+1 project I announced a couple years ago and haven't really gotten around to yet. At any rate, this, as you can see, where the faceplate opening is a little bit too wide, so I just put a little spacer in here and just sort of push the chassis and faceplate up against the opening. And this has turned out really well. One of the things you need to consider in doing this is whether you want this border to show up around your faceplate. You will always see this border if the edges of the faceplate are visible. If you don't want it visible, you can just overlap the faceplate by a 1/16 or 1/8 of an inch, as I've done over here on the corner under the Mollerup Ampworks logo. Personally, I favor the way that looks, but there's nothing really too wrong with having a lit border either. To do the edge lighting, I've used a cuttable Cobb 320D 5-volt LED strip. That strip has 320 LEDs per meter. You can cut it every inch. So I've cut it down to 12 inches and put it in just temporarily over top of the faceplate in the mock-up over here. A meter is 3.28 feet, or just a little bit, a hair over 39 inches. So taking those things into account, 320 LEDs per 39 inches, and dividing that, we come out with about 8.2 LEDs per inch. Really, it's 8 LEDs per inch, and I've counted it. Every inch there's 8 LEDs. Being that the faceplate is 12 inches wide, I'm going to use a 12-inch strip on there. So that's 96 LEDs. This is important to know because we need to calculate what the current draw of that LED strip is, so we can sort out what power supply we need. We know that the strip is a 5-volt strip, and we need to calculate how much current we're going to draw so that we can appropriately either design or buy power supply. This LED strip uses 8.64 watts per meter. Knowing how many watts per meter and how many and what the voltage is required by the strip, 5 volts, we can use Watt's law to calculate what the current draw should be. It wasn't specified, so we need to calculate it. Watt's law says power or wattage equals voltage times current. So considering that we know the wattage, 8.64 watts, and we know how many volts the strip is, 5 volts, we can divide the wattage by the voltage to come up with our current. So 8.64 watts divided by 5 volts gives us 1.73 amps for the entire 1 meter strip. Knowing that it's going to draw 1.73 amps and we have 320 LEDs in an entire strip, we can calculate how much current is drawn by each individual LED by dividing that 1.73 amps by 320. And we come up with 5.41 milliamps per LED. We know that in 12 inches, we are going to have 96 LEDs. 8 LEDs per inch times 12 gives us 96. So if we multiply 5.41 milliamps by 96, we get 0.519 amps, or 519 milliamps. So I know that my power supply needs to be able to provide 519 milliamps for the strip I'm planning to use. I'm going to have the LED edge lighting switchable on and off, but we still want to know when the amp is turned on, even if we're not using the edge lighting. So I'm putting a yellow pilot light in there as well to match the yellow LEDs around the edge. The pilot light I got is also a 5-volt pilot light. And I already, the specs were already published for that when I bought it. It draws 20 milliamps. So our total current requirement for the lighting in this amp is 519 milliamps plus 20 milliamps. So 539 milliamps is what we are expecting the lighting for this project to draw. We can round that up to 600 milliamps. It's close enough and easier to deal with that round number. For safety, we will get a power supply that can provide double that. So we want to source a power supply or build a power supply that can provide 1.2 amps of current. I thought about working it out to come off the filament string, but that's a little bit more current than I would be comfortable drawing through the filament wind. And so it left me with it left me with the option of designing my own power supply and building it, or just getting a pre-made power supply module. And there are lots of them. They're inexpensive. For the time it would take me to get the parts, build one, make a PC board, it was just worth it for me to just buy a switch mode power supply module. I will have to pay some attention where I put that module because it could introduce some noise in the preamp. I've got a lot of room in there now with the bigger chassis, so I don't think it will be a problem. If it is, I can build a little Faraday cage around it, and that should deal with any of those sorts of issues. The power supply that I've sourced, I actually found it on Amazon, and it's it can provide 2 amps of power, so way more power than I need. So that's great. There's nothing wrong with having a power supply that can provide more amperage than you need. You have problems when you're pulling more amperage than the power supply can keep up with. In a nutshell, that's what I've come up with in playing around with this mock-up. I'll be using a Cobb 820D string. It's a strip. The strip is 8 millimeters wide. The LEDs are not 8 millimeters. They're actually really tiny surface mount LEDs. But the strip itself, which has an adhesive back, is 8 millimeters wide. These LED strip lights, because these are packed so closely together, 8 per inch, it can generate some heat. It's probably not a problem, but it's a good idea to have some sort of heat sinking. So I'm going to just get a 1 foot piece of 1/2 inch by 1/2 inch aluminum angle and put the strip on there. And then I can also, it serves a double purpose. I can drill some holes in the angle and mount it right over top of the chassis. One of the other things that I'm going to need to deal with is the way that I'm putting the strip on. It's going to be the angle will go like this, so it'll be screwed on like this. The strip will be on this top part of the angle that goes like this, but it's still quite bright and throws a lot of light out the back of the amp. That is a cool look, but it might not be great to have that all the time, especially on a stage or something like that. So what I'm thinking of doing is actually mounting a cleat on the back of the upper part of the cabinet, and instead of mounting the angle so that it's on the back of the cabinet over top of the faceplate, like this, if this were the front, what I'm going to do is put it on a cleat so I can mount the angle like this. So front of the faceplate will be here, and then that angle will be mounted to a cleat like this. So there'll be a little bit of a drop here. So when the LEDs come on, it shades a little bit of the light coming out of the back. We'll see how that looks. So that's my idea with that. The front panel LED pilot light will always be on if the amp's on. Whether the edge light is turned on or not, the pilot light will always be on. That's why I picked one that had the same color as the edge lights, although it would look kind of cool to use complementary colors, or I could have used a red pilot light with the yellow edge lighting. That would look okay. So again, just a sort of quick bonus video, just to sort of show you the proof of concept here on the edge lighting. I'm really happy with how this looks. So that's it for this bonus part 6B of the bass preamp build. Like always, please like and subscribe. Check my band Once All Thrust. The links are in the description below. It's New Year's Eve today, so have a great night tonight. Take care and drive safe, and we'll see you in the new year.